Hello, good day. We're here in week 3 of Econometrics Lab, and for this first video, we are going to do some more tidyverse material, such as reshaping and other things, importing an external data set, reshaping that data set. And we're also going to talk about the addendum, which I really should have put in the original slides anyway, which is the merging of data sets. And then in part 2, we will go and do ggplot. So that's for part 2. All right, so let's start. So in this Econometrics Lab, one of the most important tools will be displaying the raw data or some aggregated form of the data. So there's a discrete data, such as a 1 or 2 or Philippines or Hong Kong, right? And then there's continuous data like price in pesos or weight in kilograms. We will learn basically a scatter, a line plot, and a bar plot. So a scatter plot is your general first plot. You want to do a scatter first for anything. A line plot is what you'd like to do if you have time on the x-axis. So you want to see if it trends up, it trends down. So time series lends itself to a line plot very well. And then a bar plot is something you do if the x-axis were categorical, like different places, Philippines, Hong Kong, China, etc. Right. And so we will be learning all of that. And finally, we will be learning density plots at the end. But that's for ggplot. First, we will learn how to import data and then manipulate data with ggplot, with tidyverse. So let's start. Let's bring in our data, which should be in your project folder. So let's open it. This is my project folder. For this class, this is the data wrangling tutorial, which is also in the Canvas website. Please download. I have loaded read Excel and tidyverse. You can just run this, then we can check your directory. So this is now my directory or working directory for the project of this class, Econometrics Lab. So let's read in the data. So I just repeated the packages that we'll be needing. This is the data set itself. So notice that this is my working directory, and within the working directory, we have here the file itself. And if the file is in the working directory or is in the project directory, then you don't need to enter the full address or the full path to the file. You can just name the file directly. Now, from the package read Excel, we will be using this function, read underscore XLSX. And as usual, we will be using the question mark function name. And then you'll see here that it's part of the package. So in order to use it, you need to load the package, install and load the package first. And by the way, if you don't have it, you should install the packages like through here, install, and then read Excel, and do it that way. Okay. Next, once you have installed and loaded them both, so we will load them both again, no warnings, it's already there. You can check here, for example, tidyverse has already been checked. That's the other way of doing it. You can uncheck and then recheck to load it. Next, what we would like to do is to import it. And as you can see here under help, the path is the first thing, the path to the file. And since this is in the directory, the path is itself the working directory, right? Which you can skip. You don't have to write it, so you just write down the name of the file itself. Okay. So the path is the file name with the full path leading to the file name, which you can skip if you're using the project directory. Next is sheet null. So what does sheet do? The sheet is the sheet to read, either a string for the name of the sheet. So in Excel, you can name them. And if it's named, then you can enter a character vector here, a string, a character vector. Or an integer, the position of the sheet. So the leftmost sheet versus the rightmost sheet. And then you can count that. There are other arguments or inputs, such as the range and the column names. What's interesting here is the column types. Okay, under column types, the null is the default. Either null to guess all from the spreadsheet, or a character vector containing one entry per column. So if it's null, it will guess what the type is based on the first few observations. Okay. Alternatively, you could supply the type of data within the column. Okay. But you can, at this point, it's enough to just guess. And if the guess happens to be incorrect, you can change by mutating a column, turning it into numeric if it's a text, etc. Alright, so let's do it. And this is rice dataset, and here's our tibble or data frame. Now a tibble is a enhanced data frame, but you can always just treat it as if it were a data frame. Head rice gives the first number of observations. So if you were to do that, you could look at this. You can see the first 5 observations. What's nice about a tibble is that you can automatically see what the type is whenever you call on the software to print the data frame. So here, city is a character, stat is a character, special, all of these columns are numbers. These are double, which is the amount of data in the number, double. And then you've got 10 more variables, which are all of these things. Okay, so that's our data. So what's in this data frame? Is this long or is it wide? So in our data, we are going to investigate right now what a long data set is and what a wide data set is. But before we continue answering a question of whether it's long or is it wide, we should figure out the things that are in it. So understand what's in the data frame. So here you'd see the markets or the cities where the observations are taken, the dates. Okay, you've got Feb 15, 2017, and you've got Feb 24, all for the Gupan in this case, average, min, and max. So each line, for each city and each date, you've got 3 types of statistics that you're getting. And then for each statistic, you've got a bunch of these columns. And it's rice, so it's actually the kind of rice it is. It's special rice, premium rice, and you have WMR, which is well-milled rice, and then RMR, which is regular milled rice. What's also interesting here are the numbers. So the specials, there are 5 specials, 1, 2, 3, 4, 5. And that's for each city, right? So for a city and a specific time and a specific statistic, the average for a special rice in number 1 is 45.6. Special 2 is 42.8, and so on and so forth. Okay. So these are like stalls. These numbers are like stalls or places that you would go in a particular market. Someone from the government would look at all of the different special prices and then would calculate the average of the specials in a stall. And then there would be a min and max within a stall. So within a stall, the maximum special price is 52 and the minimum is 40, right? Okay. And you've got this spread, right? So within the city of Dagupan itself, the spread is kind of interesting, right? In stall 1, the spread is 8. And here, it's also, is it also 8? Yeah, also 8, but the mean is lower. This is 10, or a little higher than 10 actually. And then this one is also a little higher than 10. And this one is 6. Okay. So there's different spreads. So that's interesting to note. The ones with the fewest spreads seems to have like a low max. So this is a low max here. Except for this is a high spread. That has a low max. It's only 48 max versus 52 or 50. Which is a 10. Oh, this is 2. The highest one would be actually this one, right? 12. Yeah, this would be the highest one. So stall number 1 seems to be a special case. Very high prices, and the gap between min and max is quite high as well. Okay, so that's that, right? That's the interpretation of this data set. And now we have to think about whether it's long or if it's wide. Okay. So first, like we said, it's a table, not really a data frame. It's a special data frame. We can see that the data type or column, DTTM, is a date time type of POSIX CT, which means it can have a date and a time, meaning 5 o'clock, 5:30 p.m. And so it has 24 hours. 24-hour clock. We would like to turn stat into a factor. So to remind ourselves, how would you do that? You will use mutate to turn stat into a factor. And the command really is factor. Stat is the input. And you're telling the computer, hey, the levels I want for stat is min, max, and average. And if you sort stat, what's the new order? Well, min will be first, max, and then average, as opposed to alphabetical. So let's do that. I think we have it here. Well, first you'll find this. You can turn a character into a vector, into a factor. So first you want to do it without mutate. And as you can see here, you can feed it the vector, and it will output the team output. It will output levels of average, min, and max, and all of it, and basically a vector of length 798, of which the order or the levels of the different characters are average, min, and max. And you can change the order here, and so on. But now let's continue by doing this. And we convert stat into a factor. Then let's look at rise again. Stat is now an FCT, or a factor. And if you were to order it, it would be min, max, and then average. That would be the new order. And I'd like for you guys to sort this data set yourselves using the command would be order. Okay. Or actually, hold on. It's not order. Arrange. So arrange is the plier. Arrange rows by the column values. So what you'd like to do is to arrange the rice data set. Arrange it dot by the variables. So you can have variables or functions of variables here, and you can say set. And as you can see here, the mins go first. Then what's next? The max, then the average. Okay, moving on. If you wanted to, you could so this does not permanently rearrange a data set, because this just rearranges it and shows you what would happen. If you wanted to rearrange the rice data set permanently, I just want to show you that it didn't. See? It didn't. If you wanted to do that, you would have to assign it to the rice data set, which would overwrite the old rice data set. We don't have to do that. All right, so next, we will talk about reshaping a data set. And that is related to long versus short, right? We would like to know what our unit of observation is. The plotting software, the ggplot package, would like to have it such that each row is an observation. But an observation from our point of view could be different depending on the level of aggregation. In the rice data now, the columns are the varieties of rice matched with a stall number, special one, like we talked about. We want to reshape it to make it a long data, and where each row is a city, stall, rice variety, and date. Why? Because we are believing that the observation is at the stall level, right? You've got the stalls are in cities, monitored on certain dates, and certain statistics are taken from a stall. So each row in the dataset should be a stall. Right now, each row is a city and date, and the columns themselves include information about the observations. So if we believe that it's a stall dataset, then the unit of observation can change. We can talk about that later. But right now, the unit of observation is the stall. So right now, the observations are found in the columns and not in the rows. What we would like to do is to make sure that each row is an observation by putting all of the things that are in the columns right now, which are the stall names, down as a row. Okay. So let's take a look at this. The command that will turn it this way are in the R file, which we shall go to right now. Okay, so you can use pivot longer. Okay, starting in 2020, there are newer verbs to do gather and spread. Use pivot longer and pivot wider. So this is the command, right? Pivot longer calls, which is you do the minus because you don't want to pivot city, you don't want to pivot date or stat, so you want to exclude those things. The names too, that means all of the column names will be sent as rows called varieties, and the values, okay, will be called value. So currently, right now, the values are under special 1 and special 2 and special 3. What we would like to do is to create a column called values and create a column called varieties here. And notice that special 1, special 2, they used to be the column names. And now we want them into different rows because each one is actually a stall and a type of rice. And then these are values, which are the prices. Okay. So actually here, instead of values 2, you could rename this as prices or average or values or whatever. You can name it whatever you want. This is just the name of the new column that you're creating that will contain all of these numbers here. And you're also creating a new column called varieties that will contain all of the column names here. So let's do it. And that's what we got. We've got cities, dates, stats, varieties, and values. Okay. So there are a couple of other problems, right? First, these statistics would probably be best if they were columns, because these statistics aren't part of our observations, right? It's not, our observation is at the stall level. So we'd want city, date, variety, and stall number. Okay, so these ones which are sort of a description of the values, really should be in the columns. Okay, especially if you want the observations to be over. Next, varieties contain two things: the actual variety and the stall number. So you want to separate that out. So in that sense, there is that problem, right? Let's go here. So those are what's wrong with it. The stats, you'd want to move them up, okay? And the varieties, you wanted to separate them. So first, we would like to mutate by creating a new column. In particular, we want to create a column called stall, and we want to create a column called varieties. Both of them come from the current column called varieties, because the current column called varieties are a number and a character vector, right? Like special 1, special 2, etc. What all this is doing is this is called a regular expression. And what this is doing is it's looking at the column called varieties. It's looking for all of the text, and you're replacing it with nothing. So basically, give me all the text and replace it with nothing. And I'm going to call that stall. Okay. So the special 1, the word special will disappear. And then it will create the stall. So that's why you've got 1, 2, 3, and 4. Now, the varieties here is the same, but instead of looking for the character, you're looking for the numbers. And you look for the numbers and you replace them with 0, and that's why the varieties will continue to be varieties, special but without the numbers. And that's how you produce this one. Now, since you're naming varieties the same as this, you're overwriting the old varieties with this command. You're creating a new column called stall, and you're overwriting the old column varieties with this command, because you're naming them the same. If you had named this like varieties 2, you would then create a new column called varieties 2, keeping the old column varieties with the variety and the stall number. So let's look for that command here, creating new columns here. Oh, so first, we'd want to make it long, right? And assigning it now to the rice column. So this and this is the same, except that now you're making the change permanent by assigning the new configuration to the old dataset. So let's try it. And if you call on rice, it will look like the same. And again, the problem is this average here is here, which is not supposed to be here because each row should be an observation. An observational unit, and the columns should be the different statistics or the things that you are measuring about each unit. And now what we'd like to do is to pivot wider. In order to turn all of this into columns, you would want to take all the names from stat, so average, max, and min, and then you're turning them into column names. So that's what names from means. You're creating new columns, taking the names from stat. The values are taken from values. So now you've got 3 different columns called average, min, and max, whose values are taken from the column values. So let's look at that. First, let's run it without assigning. And as you can see here, you've got average, min, and then max, all in different columns. And each row is a city, a date, and a variety, which currently has a variety and stall combination. So we want to have this permanently. And now when we call on rice, it's like that. And next, we will create a new column, like we've just said. First, I won't assign it, just to show you what it will look like. And like we said, in stall, you're creating a new column that basically takes the data from varieties, removes all of the text. And here you're overwriting varieties by removing all of the numbers. And we can do that now, rewriting over rice, and we can now have this, which is what we would like to call our long data set. Okay. we would this is now our long data set, wherein each observation now is a row. Each observation is a row, which is a city and a date, a stall, and a variety combination of arrays. Okay, so that's the difference between long and wide. If it's long, then each row is an observation. If it's wider, or if it's a wide data set, then you are moving some of that observations data, identifying each observation up to a column, and then you're turning it into wide. So this data set would be a long data set, and this original data set here, this would be a wide data set. Okay, and that would be a wide data set. Okay, and we will now move on to the addendum, which is called merging. Okay, so this is one last topic. Typically in an empirical project, you want to combine different sources of data. So like before, we will use tidyverse functions, specifically two, inner join and left join. I enjoin you to study right and full join on your own. So a note on merging. So we merge using key variables. A key variable connects two data sets together. There can be multiple key variables, or variables common to both data sets. It's possible that the variables common to both data sets have different names, and we can work with that. Now let's call these two things that we're combining data frame A and data frame B, right? A and B. If there's a match, then the matching rows in B and A will be combined. If there are more matching rows, additional rows will be included in the combined data frame. Typically, right? Let's use the examples in the tidyverse package. So let's require tidyverse here and then call on band members. It will create a short table with the name column and the band column, both are character vectors. And then there will also be another data set available called band instruments, which is another short one with the name and the place of instrument. So the name here is the key. It's the common variable that you can combine the members and the instruments. Second, I wanted to point out is not all names in members are in the instruments. So Mick, John, and Paul. We've got John and Paul, but Keith is here, but Nick is not there. Okay. So an inner join says that the first data frame and second will be joined by name, and only those matches for both will be kept. So that's why it's called an inner join. Only those matches for both will be kept. So we've got band members, pipe, inner join, and then the name of the second data frame. It will automatically join by all of the columns with the same name. It will realize, or it will force, if you have two columns with the same name in either dataset, it will assume that that's your key. So if that is not your key, then we have to tell the computer later on that that's not the key, that you have to choose a different key. You can specify the name of the key later if you wish. But it simplifies things by assuming that all columns with the same name are in fact the key. So joining by name, you've got John, Paul, Beatles, guitar, and bass, because these are the only two matches. Remember, not all the names have a match, as we just discussed. The left join says that the matching rows will be taken from the first data frame, which is band members. Band members, pipe, left join, band instruments. Joining by name, you've got Mick, John, and Paul. So these are all the names from band members, because we are keeping everyone in band members and including data from place, but you're keeping rows from band members. But take note that there is one band member which does not have an instrument. So that's why it will call NA. the software will describe that as NA because there is no corresponding instrument here for that specific name. You can have multiple columns. It will take all the columns with the same names and match them. So here we're creating a new column for in A. So A is band members and B is instruments. You're creating a year column for both 97, 98, 98, 97, 98, 98. So you're doing an inner join. For some reason, there's two of them here. And then joining by name and year. So now you've got an inner join of A and B where it's only the ones with the common year and the common name. If the year and the name isn't common, then it will not be included. And right now, because you added a year, it's only one row which has common information from both A and B, band members and band instruments. Whereas before there were two. Okay, so John in band members has a different year than John in band instruments. All right. So it's that simple. There are many different ways to complicate merging, again, by having different names. We will deal with that issue when it comes. But right now, know that if you have two different data frames, they have the same names, then they would all be used as key variables. And if that's not what you want, then you have to specify what the keys are. So for completeness, let's just do that. So let's look for inner join here. And there is a command here called by, which allows you to specifically name the character vector to join by. Okay. And if you don't supply it, it will just assume that all similar names are the keys. To join different variables on X and Y, it's possible. You use a named vector. So for example, if you type by equals CA equals B, it will match X is A to Y is B. So this is another way to do matching with different names. Okay, that's it, and I'll see you in part 2.